To understand the basics of Lambda expressions in Java, how they simplify code, and to practice using them in various scenarios, you need to have a basic knowledge of Java syntax, understanding of functional interfaces. Well, a good starting point is the official Oracle documentation. Let me open this in a new tab. And so here you have a section of topics for Lambda expressions. You have the approach one, which is create methods that search for members that match one characteristics, all the way up to uh, use aggregate operations that accept Lambda expressions as parameters, GUI applications, syntax for Lambda expressions, and so on and so on and so on. Right, so here we have approach 4, which specifies search criteria code in an anonymous class. Alright, so one of the arguments of following invocation of the method print persons is an anonymous class that filters members that are eligible for selective service in the United States. Those who are male and between the ages of 18 and 25. Roster, check person, return. Alright, so return the person P. Okay, so return P. Get gender, person dot sex dot male. B dot and B dot get age. 18 and P dot get age less than or equal to 25. This approach reduces the amount of code required because you don't have to create a new class. Yeah, technically you don't, right? Publicly, yeah. For each search that you want to perform, however, the syntax of anonymous classes is bulky considering that the check person interface contains. Well, so yeah, you have your documentation from the oracle.com website. Moving on, then to task number 2. After you're done with research and understanding the syntax of basic usage of Lambda expressions, we can now write a simple Java program that uses a Lambda expression to implement a functional interface. Use the runnable interface for this task. Let me go ahead and open BlueJ for this, and let me minimize this window and create a new project. And I'm gonna call this Lambda Lambda expressions. Say Lambda expressions. Let me shorten to say Lambda express. Yeah, so Lambda express, and let me create a new class. Say I'll say. I'm sorry. Let me get my glasses here. Try to see properly here. Okay, this is much better. All right, so Lambda expressions. All right, let me shorten this here to the side. All right, so yeah, so write a Java program that uses a Lambda expression to implement a functional interface. Use the runnable interface for this task. Okay, so let's go ahead by putting a public class, right? Here's a Lambda expression. Let's say Lambda expression. say public static void, say main here. Get my string parameter with my arguments. And use the runnable interface for this task. So runnable interface, functional interface. So let me say task, right? And I'll use these parentheses, which is the method, and I'll use the arrow operator, and I'll say system, the print line, and I'll say, let me see, lambda, let me see, creating. Lambda expressions, right? Yeah, let's see what this is at. Okay, let me do a new thread here real quick. Let me say new thread. And I'll say task. And I'll say start. Alright, so creating lambda. Let me have this over here. So creating lambda expressions. Okay. Not bad, not bad, not bad, not bad. Okay. Not bad, not bad. Just, here we go. Alright, so then we move on to task number 3. So task number 3 is using lambda expressions with collections, right? We're gonna sort a list by, sorry, task number 2 actually jumped here. So we will write a simple Java program. All right, we're done with that. So we're gonna using lambda expressions with functional interfaces. We will create a functional interface. Define a functional interface named math operation with a single abstract method operate integer a and integer b. So define a functional interface named math operation, and then write a Java program that uses lambda expressions to provide implementations for math operation. Implement addition, subtraction, multiplication, and division operations. Okay, so again, so we'll define a functional interface named math operation. Okay, let me have this here. So I'm gonna say interface here named math operation. With a single abstract method operate. All right. So that's going to be integer operates single, say integer a, integer b, and we can create here an annotation here. Since it's functional, we want the compiler to enforce, right? The functional interface. So if that's correct. So a functional interface. This annotation here essentially is not necessary, but as I remember through reading my professor's modules, it's recommended that way the compiler enforces, right, that this is a functional interface. So that's it. What else? All right, and then we write a Java program. So let's, I think, write this over here. So then we write a Java program that uses Lambda expressions to provide implementations for math operation. And so we're gonna implement addition. So we're gonna implement addition. Okay, so let me see here. I'll say, I'm saying math. So let's say math operation, right? Let's say add. Addition, right? So add. I'm gonna say. So we're gonna pass these arguments, right? So I'm gonna say a, b, right, which is short for integer a and integer b, and we're gonna have the arrow operator and pass it a minus b. A minus b, and we can go ahead and save ourselves some time by saving this, and then what do we have here? Don't know why all this happens to me, but hold on. Okay, so this one more time here. So we're gonna implement addition, subtraction, multiplication, and division. So here we're gonna say, what is this? Subtraction. Subtraction. I'm gonna say subtract. Right. Correct this by saying plus. We can leave that, and then we're gonna say. Then we're gonna say multiplication, right? So we're gonna multiply integer. Multiply, and I'll do this here, and division operation. I'm gonna say divide. Alright, and as simple as that. Divide. I might use a ternary operator, because if b, if b becomes 0, you can't divide by 0. It'll be, I mean, something here. Let me see something here. Let me see if by null, essentially. Yeah, so the calculator gives us undefined. Okay, so I'll say, let me say here. So I want the calculator to, so I want this operation to run as we're gonna have here. So if b, I'm gonna say if b is not null, right? If b is not null, Let me see something like this. So if that is true, then we run this operation here. So what this means is, okay, let me complete this first. Yeah, 0. So this is a ternary operator. Ternary operator. So what this means is that we want this to run, right? We're gonna test this condition, right? We're gonna test this condition. So we're gonna test if b, the integer b. So if integer b is not 0, meaning if this statement here is true. So what that means is that if this statement is true, then run, and the question mark here just means that it waits to see if this condition is true or false. Meaning, if it's true, then run whatever whatever comes before the colon. So whatever statement we have before the colon, it'll run if this is true. If this is false, meaning if b is indeed 0, then we run 0 on it. We're gonna run 0 on it, right? And then let me test some here. Let me test a little bit here. Let me say system dot print line. All right, so let me say addition, right? So addition, and I'll say add, right? Operate. Okay. And we're gonna say, I mean, this is basic addition. You don't really need to think too much about it. A basic 5, basic 5 plus 9. All right. And let's go ahead. Oh, actually, we don't even have to put in the comma here. All right, comma, and let me just go ahead and copy this here. Just copy this line here. Savior. All right, so let's move here for subtraction. Subtraction. And let me say here 13. And then what is this here? Multiplication. So multiplication, we're gonna use here, we're gonna change here to subtract. We're gonna change here the operation to multiply. Alright, let me change this to, yeah, it doesn't matter. Let me just say a basic 2 here. Let me change this to division. Okay, division. We're gonna divide the operator here. Divide. Let me change this to 2 for now. Let's go ahead and compile this and see what we have here. Okay, so we have addition 14, right? So 5 plus 9, 14, that is correct. Subtraction, we have 13 minus 9, that's 4, correct. Multiplication, 5 times 2, basic. And division, 5 divided by 2 is 2. And it gives us only 2 instead of 2.5 because this is an integer, right? This is an integer, so it will remove the decimal. It will remove any decimal from it, unless if we run this as double. Let's test a quick double here. Let's test a quick double here. And here we got here 2.5, right? So double will give us 2.5. However, integer will give us 2. Okay, so let me change this to a 6 for now. Let's try to divide this to complete this division by null, right, by 0. Let me clear this real quick here. Right, 0. So, yeah, right. So you might want to ask yourself what happens if we don't have this, right? Let's comment this out. Let's comment this out. Right? Let's try and run this and see what we have here. What happens to our program? We don't. So we get an arithmetic exception here by 0, right? So we get an exception error. This is what we get. So essentially, this helps our program from crashing. All right. Let me go to for that. Okay, so here looks good. Seems good. Seems good. Now task number 3. Let me go ahead and save some space here. Okay. Okay, task. Okay, so now let's sort a list. We're gonna write a Java program that creates a list of strings and sorts it using a Lambda expression. Again, write a Java program that creates a list of strings. Okay, so let's go ahead by creating a list of strings, right? A list of strings, and what should we call this? And sorts using a Lambda expression. Let me just say name here. Alright, we're gonna call name here, and we're gonna say array. Right, so as list, and I'll call here Alexa, and I'll call Bard. Let me say Gemini. I'll call Claude. Or ChatGPT, I think it's more popular. Let me call ChatGPT. Right, so write a Java program that creates a list of strings and sorts it using, okay, So we want to sort this. I'm gonna import. Let's import. Go ahead and import this. Okay, so let's import this and say name, right? Name. Sort. Let me say. So let me say string one, string two. Right, we're gonna use the arrow operator. We're gonna say so s1, and I'll say compact to and I'll say compared to S2, right? Oops here. And then let's do a system. See a system. Sort. Okay, so sort. Let's say sorted names. All right, so we have a quick area expected. Hold on, let me read this. Oh, okay, so we're sorting this whole thing. Let me do this. So this calls here, and this. Hold on, let me see. See. No, wait. Let's try this again. Name sort. Pair. To. Oh, okay. We need the. Ooh, you cannot forget this. Let me say. This. We need the. I always forget what's called the parenthesis. Or starts. Wait on. Let me see. So we say the name sort is inside, and this one should get. So that means that this one should have a double. Yeah. So the name sort, we sort all the way to here, and then this is the arguments, and then, yep, arrays. We can ignore this for now. I believe we should just import. We should go ahead and import that. Well, we can leave this for now. Okay. So no. Oh no, actually, let me do a quick. I'll go ahead and import everything. So let me go and. Oh, I already sorted it. Let me go with. Let me say. Alexa, right over here. Let's go ahead and do that one more time. Let me change this. Let me have part over here. Up. Okay, let's clear this and let's run this one more time. Oh, I didn't compile it. Okay, let me do this one more time here. Let's have Alexa here. And let's have. Okay, this is fine like this. Now let's have Bard all the way here. Okay. So we have here Alex, Bard, and Chat, right? A, B, C. And you might be wondering, but hold on, you only passed, uh, where is it? You only passed essentially two arguments, but you have three arguments here, right? Three argument strings. So this is a sorting algorithm, and to be honest, it probably would have to be in a different video, a longer video. But a sorting algorithm essentially just pulls so let's see it this way. Okay, so it'll connect string S1 and S2, right? So it'll say S1 and S2. String S1 starts with C and string S2 starts with A. So let's switch, right? It's gonna switch, right? Then it the compiler will jump will jump. I think yeah, that's how it's not bubble sort. But what what I'm trying to explain is that the compiler will know that your that index 0 is already sorted. So then it will go to the next index, right? And it will start from index 1 because it knows that 1 is not in a ideal. I don't know what how to explain, but so then it will again compare now the index 1 to index whatever index is to the next, right? So to compare index 1 and index 2, and then it will see that okay, let's do it like this. Let me maybe say, so I'll just do like this, right? So okay, originally we have C, A, and then B, right? So the first algorithm, right? And as you all know already, what an algorithm is, right? Which is a step-by-step instruction or sequence on how to complete a task. And so we give the system a sort of S1 and S2 and compare S1 to S2. And so it will compare C and A, right? And so it knows that A comes before C, so it will switch. A goes up, C goes to the right, and A comes down. So then it will be like this: A, C, B, right? Then it will run again, and it knows already. It won't start from index 0, right? Because it knows that A is already sorted, right? So then it will look at C. It'll look at C and then it will look at B, and it knows that B comes before. Um, it knows that B comes before C, so it will switch B and C, and then it will print it out like this, right? And then if it has to run again, it will look, okay, it already knows that A is sorted, already knows that B is sorted. It'll come to C, and is there anything left? And there's nothing, so it will close. That's how it will run. And we can test this by including one more string here. Let me add, let me say Claude. Let me say Claude. Let me say Copilot. Let me say Copilot. Copilot. All right, I know it should be something like this. So Copilot, Let me add one more. Let me add what else? Let me add XAI, right? Or is it like this? I don't know. But yeah, XAI. Let me extend this a little bit more. Of course, there are many other videos about sorting. So if you want to understand more about sorting, you can do that. I'm not a specialist. I do want to emphasize this. I'm also just learning. But all right, so let's run this. And, we have it all messed up, right? Let's see if it sorts the way we explained. So it guess for us, right? Alex. Oh, it's actually Alexa. Hold on. I just realized it's actually Alexa. Um, Alexa for Amazon. Hold up. Sorry. Just adjusting or something. So let's, yeah, Alexa. Everybody knows Alexa. I don't have to explain Amazon. So yeah, Alexa. So we have here Alexa, Bard, ChatGPT, Copilot, and XAI. You realize that ChatGPT comes before Copilot, even though they both have C, but because H, right? The compiler will look, okay. So we have two strings here with the same initial. Then it will look to the to the next character, right? And it will see H, and then it will see O. So immediately it will stop. Then it will know that chat will come first, and then co will come after, and then X, of course, will come last year, right? Even if I put X here, I'll put X first. I'll put X first, and I'll put it right over here. And I'll compile this, and I'll then run again this algorithm, and still it will sort it, right? Because it goes back to that explanation that I gave, right? It'll be switching, right? So the first sequence, it will switch ChatGPT with X, and then it will switch. Um, okay, this is interesting. So you might now ask, okay, so if it switches X with C, would that then mean that it won't run again? It won't run again. C, right? Well, I'll say this. It depends on the type of algorithm you're using, right? There's a lot of there's the bubble sort. There is forgot the names. Forgot the names. But depending on the type of sort, right? The compiler will know how to. It'll even if it runs C to X, right? And then it will compare X to A. But then it would know, okay, so there's an A, meaning A is bigger than C, which what was from the first house that he already stored. So it will go back to the house, and when A comes here, right, and then you compare A to chat, right? So Alexa to chat, and it will switch. Then it'll go back to X and then compare bar to X and then come back. But then as it connects to bar, you know that B is, it's a whole mess. Oh my goodness, that was a bad explanation. But anyways, let's move forward. Okay, so we're done with sorting, and then let's go with filter. Filter? Write a Java program that creates a list of integers. Is that part of task 3? Okay, it is part of task 3. Let me just shorten this a little bit here. All right, so where are we? Where are we? Write a list of integers, right? And I'm gonna say your integer, a list of integers, and filters out even numbers using a lambda expression. Okay, so I'm gonna say numbers, and I'll say arrays, right? As lists, and it filters out. Okay, so let me just go ahead and say, right? let's say 1 all the way to 3, all the way to 9, and filters out even numbers using. Alright, so we're gonna say numbers, and I saw these in my professor's modules. He used something like stream. He used a stream, then filter, right? So it knows. So filter, we're gonna use the arrow operator. So n, and so if the quotient of n divided by 2, right, is not equal to 0, right? So essentially whatever n integer is, whatever n's remainder, as long as it's not equal to 0, right? If it's not equal to 0, and I'll do a for each, right? I'll do it for each, and I'll do an system. I'll say n, we're gonna print n plus, let's say this, right? And let's go ahead and, oh, let me pull this over here. Hopefully you guys can see. All right, let's the system. Print 9. Let's go to n here, right? Okay, let's compile this. Oh, quick. Typo, system.print. Oh, we didn't do out here. Let me do it out here. Okay. What now? Undeclared variable? What do you mean by undeclared variable? I'm just a system.print. So look at me, silly me. I'm already printing out here. Okay, I'm already printing out here. Okay, let me say force of habit here. Alright, so out of this list here, we have 1, 2, 3, 4, 5, 6, 7, all the way to 9, and we know that the odd numbers are 2, 4, 6, and every number that divided by 2 has no remainder. And so what this does is that, so if n divided by 2 is not 0, meaning 2 divided by 2 is 2, meaning the quotient, right? Which the quotient is whatever comes after, so whatever comes after the decimal point, right? So 2 divided by 2 is 0, and let me go all the way to 5, right? So 5 divided by 2 is equal to 2.5. So this 0.5 here, right? So this 0.5 is what is not equal to 0. So if it's not equal to 0, then for each, right? So for each n, which is going to be 3, so essentially 1, 3, 5, 7, and 9 for each, right? We're going to do a system.print n, right? And with a comma here. With a comma. Right. Let me see what the instructions say properly here, right? Filters out even. Yeah, that filters out even numbers. It filter. Well, it depends if by filtering out does it mean yeah, so filter yeah, filters out. Yeah, so filters out, so that means only the odd numbers. Okay. Only the odd numbers. And then let's go ahead to task 4 here. Let me clear this out here. Let's go for task 4. How many tasks do we have here? 5? Task 4. All right, so task 4 is oh, sorry. Write a Java program that uses the predicate functional interface to check if a string is empty or not. Write a Java program that uses the predicate functional interface. Oh, okay, so a functional interface. Okay, let me have another interface here. And again, functional interface, so we want to have an annotation here for functional interface. Let me make sure it's correct yet. Okay. I'm going to say interface. Well, what are we going to call this? To convert a string to uppercase. To convert a string to uppercase. No? Write a Java program that uses the functional interface to convert these. Wait, hold on. I'm confused here. Write a Java program that uses the predicate functional interface to check if a string is empty or not. Oh, predicate functional interface. Okay, let me do this. Let me do the interface here. I read functional, so I assumed it's gonna be a separate interface. Okay, so we're gonna just use a predicate here because in itself it's already a Java interface here. We're gonna say string, right? Yeah, to check if a string is empty or not. I'll say is empty, and I'll say um, let me say to check if a string is to check if a string is empty. A string could do a method reference here. Let me say string is empty. Okay. And let me say system and I think okay, we're gonna say we're gonna say um, string say let me say string empty, and I'll do a is empty, right? Let me say test here. Let me comment this out here. Just go ahead and just delete this here. Alright, so this belongs to the util function predicate. Okay. Yeah, I read that wrong. I thought it was a functional interface over here. So okay, this is also a functional interface. Compile that. Let me run that. Let's see what we get here. So is string empty true? Okay, let me select this. Does this look good? Let me see. Yeah, this is better. Alright, so it will test if this string here is empty or not. Let's do that one more time. This looks better. So is string empty true? And if string is not empty, compile that. False. A space is also considered a character, but just for better reading, I'll have like a string there, and we're gonna say false here as well. False, right? Okay, so we got it running here, predicate, and then write a Java program that uses the function. You know, these wordings are, man. What? Write a Java program that uses the function, functional. What did he ask for me when he mentioned that? So I know what the wording is. Write a Java program that uses Lambda expressions to provide implementations for math operation. Oh, okay, so define a functional interface named math. Okay, so it will tell us to name it. Okay, so define. And then here is write a Java program. Okay, so that means that function is also just a already existent interface, existing interface. All right, so let's say string, right? Is it string? To convert a string to uppercase. Okay, I'll say to upper. I'll say to upper. And I'll say string. String to upper. That's a method reference there. Let's go ahead and import function. So this comes from. Okay, so the function. Okay, Java.util function. Okay, interesting. Wrong number. What? Wrong number of type arguments required too. Okay, let me have then string. Let me see if there's any explanation here. Write our program to use function to convert a string to uppercase. To convert a string to uppercase. Alright, so then I'm gonna say system dot out dot print line. Right, I'll say line, and I'm gonna say, what am I gonna say? I'm gonna say uppercase string. Maybe it's something like this, uppercase string. Right, and I'll say to upper, I'll say apply. Right, I'll say I'm gonna say king. I don't know what else to say here. Invalid method reference. Method reference. Let me say case here. Did I write? Is there a typo here? Okay. So to uppercase, to uppercase, that's correct. Let me see your. Let me see your file. All right, and we have uppercase string king. All right, it's looking fancy. Let me go ahead and say your lambda. What else? So task number 5. Task number 5. Okay. Let's see here. Can I read this properly here? So write a Java program that composes two functions using the and then method of the function interface. One function should add 1 to a number and the other should multiply the result by 10. Let me read that again. Okay, so the function takes write a Java program that composes two functions using the and then method of the function interface. One function should add 1 to a number and the other should multiply the result by 10. Okay, so that means that I'm gonna say function. I'm gonna say function, and this number clearly should be integer, and it takes 2, so it should be integer, and one should using the and then method. Okay, so I'll say and then methods. So that means the function interface. One function should add 1 to a number. Oh, and then okay. So add 1 and the other should multiply the result by 10. Okay. So let me say add 1. Let me do let's say number, right? I'll say number plus 1. Okay, this is not as easy as I thought it would be. And then the other should multiply the result by 10. Multiply the results. I'll say multiply by 10 ByteDance. Shout out to TikTok. Anyways, but multiply by 10. Uh, Multiply by 10, and I'll say number, number, multiply by 10, right? Uh, okay. Composes two functions. So when it says write it up rather composes two functions using composes. Okay, so after we add one, multiply by 10, and then method of the function interface should multiply the results by 10. Uh, Let me say, um, I'll say combined, right? And then, so it uses then, um, and then method of function interface. Let me say multiply, because this could only make sense here, is if we multiply by 10. Uh, so then function, let me say system, let's say put line, and I'll say, what am I gonna say? Sorry. I'll say result. Let's say combined function apply. Okay, so let me just do a two. I don't know. Let's go and compass. Okay, we have an error here. Undeclared method. So it's not a method, or is it an undeclared method? Uh, and then. So and then function Java. Alright, so then that means that the result here. So so that means that 2 plus 3 is 3, and one function should add one to a number, and the other should multiply the results of this one number to 10, right? So 3 multiply the results. Okay, so that means that 3 multiplied by 10. Let me see this one here. It's also undeclared. Okay, then that can only mean one thing here. I'm gonna say and then here. Okay, so then so that means like 3 and then multiply. Oh, okay, so then this combined function runs this, and then this. Let's go ahead and compile that. Let's see what we have here. Result 30. That means that 3 plus 1, or in this case 2 plus 1 is 3, and then 3 times 10, 30. Okay, looking suave. Let's compile that. And then what do we have here? So write a Java program that composes two functions using the and then. All right, okay, I'm done with this one. Define a custom. Okay, so now define a custom functional interface named string operation. Now we define it. Okay, so that means we define it all the way here. No, yeah. Let me do this. Let me create an annotation here for functional interface, and I'll say interface. What is the name? String operation. String operation. Okay. And with this string operation, I'll say, what am I going to say here? With the method apply string one. Okay, yeah. So this method, I'm going to say, I'll say oh, look at the interface. I'll say string, right? Apply. We're going to apply string s1 string s2. Pretty simple if you ask me. Okay, it should be done here, so let me correct here the spacing. Wait, that's it. Oh, implement. Okay, so implement this interface with a Lambda expression that concatenates two strings and another that finds the longer string. Concatenation or concatenates essentially is just um, adding two strings. It's what this is here. This is concatenation or concatenates. This this is not a plus operator here or an addition. This does not add. It just concatenates. I could be wrong though, but it's close to that explanation. So to implement this interface with a lambda expression that concatenates two strings. So let me call string operation. I'll call string operation. Concatenates two strings. Okay, so two strings. Wait, hold on. Concatenates two strings and another that finds the longest string. Wait, hold on. Let me see something here. Yeah, runnable does not need one. Math operations. Concatenates. Okay, so math operations we have add and then your. So we already have string. Okay, so we already passed the argument. So no. Wait, hold on. So integer. Yeah. So now we only just concat, right? That's a long name. So concat two strings, right? Hold on, let me see. So two strings. Okay, so let's see, two strings. S1 and S2, right? String one and string two. We're gonna pass the arrow operator, and we'll say concatenate string one with string two. And again, this is not addition; it's just concatenating. It's just you get it. I'll pass again the string operation. And what? And the other, and another that finds the longer string. The longest string. So that means longest string. Finds the longest string. And we're gonna save this to S1 and S2. We're gonna have our arrow operator, and we're gonna have the length of S1 the length of S1, right, and finds another that finds the longest ring, and another that finds the longest ring. So yeah, I'll definitely use a ternary here. So S1 length, I'm gonna say if it's greater than or equal to, right. Um, so if it's greater than or equal to S2's length, S2's length, S2's length, we have a question mark here. I'll say return this one, otherwise return S2. That's just a typo here. Should be a typo here. And I'll say system.out, right? Yeah, so then I'll say print line concatenates. Concatenation. Say plus concat. Sorry. I'll say class. Gonna apply here. And I will say lambda, right? And I'll say expressions. And this is longest string. string. We're gonna apply longest string here, and I'll leave it like that as well. Let's go ahead and compile that. Oh, say longest string here. I'm gonna compile that. Okay, so we compiled, so we concatenated lambda expressions, as you can see here, right? We concatenated these words here, right? Let me do that one more time here. So we give here lambda expressions, and the longest string of this concatenation is expressions. I mean, you can clearly tell there's like 2, 3, 4, 5, 6 characters here, where there's definitely more than 6 here in expressions. So, okay, uh, what do we have left here? Um, I don't see anything. I think seems solid to me. Let me take this off here and let me see here. What do we should we? I want to remove these. I want to import solely the lists and the arrays. So, oh, my mouse bugging again. Come on. I think my BlueJ needs. I think my BlueJ needs some update. I'll figure it out later. It's been bugging a lot lately. Where was I? Lists, right? So let me go ahead and import. Arrays. Okay, much better. We don't have to import the whole kitchen, right? Less than arrays. Try to make our program faster. Not that it really matters right now here, but so let's test the program now. It looks good. And here we have it, pretty solid to me. So we created lambda expressions, addition 14, subtraction 4, multiplication 10, division 3, sorted names, Alexa, Bard, Gemini, and so on and so on. These are the odd numbers, because we filtered out the even numbers, right? So we're left with 1, 3, 5, 7, and 9, and a string empty, false, uppercase, string lambda, result 30, concatenation lambda expressions, and longer string expressions.